Hello viewers, good afternoon all. Today's teleconference organized by Dr. 𝗵𝗵𝗸𝗺 Open University, Hyderabad. You know that Dr. 𝗵𝗵𝗸𝗺 Open University is first open university in India. The university is providing printed material to the students as well as teleconferences and video lessons. Is one of the opportunity to all the students with the excellent subject experts. Today, BSc Statistics Semester 1 Conditional Probability and Bayes Theorem today we are discussing. So in this topic, there is in the teleconference is totally 1 hour. First 35 to 40 minutes about this theorem of conditional probability and Bayes theorem. In the studio there are 2 experts is there. We will discuss and explain. Then after remaining 20 minutes, the students may interact with the subject experts the following telephone number to clarify their doubts. Please note that the following number 040-23680-456. I am repeating again 040-23680-456. Before I am starting this teleconference, I will introduce 2 subject experts here with me. Professor Hara Gopal sir, Professor of Statistics, 𝗧𝗦𝗔𝗧 University, Hyderabad, and Dr. N. Raju, Associate Professor of Statistics and Head Department of Statistics, Gurunanak Institutions Technical Campus, Autonomous, Hyderabad. So today we are discussing about, I already told you, conditional probability and basics theorem. So in this we have to learn in conditional probability definitions and what is multiplication theorem of probability and also independent events. In this also we have to learn conditional probability and Bayes theorem, where we can use this conditional probability, where we will application part where we will use this will be learned in these 40 minutes with our 2 subject experts. Now I request Professor Hara Gopal sir, what is the use of conditional probability, where it will be used, sir, to give the our students?
Yeah, this particular conditional probability is actually a fundamental concept of probability theory. So this is this has got nowadays with the deep learning aspects and as well as a lot of soft computing aspects, it can be used in most of the real world applications, like for instance medical diagnosis. So this in medical diagnosis, conditional probability is used to calculate the probability of disease given the presence of certain symptoms. So that is one, and this can also be used in finance. So that is you can as well compute the conditional probability to calculate the probability of a stock price increase given the performance of the overall market. So like that you can as well go like insurance, you can as well use it. You can do in most of the marketing aspects, like you say that here you want to know the customer purchasing power, how a product is being, customer is being purchasing the product, and what is the chance that here conditional probability that he will buy that particular product in the market which is available. Then it is also used in machine learning and data analysis. So like you have Bayesian networks and decision theory approaches, Naive-Bayes approaches, and the probabilistic graphical models. So with these things, and I mean actually this theory of conditional probability is applicable in most of the deep learning aspects, like random forest, etc. So there and particularly in natural language processing. That is, what is natural language processing? Natural language processing is the process where you analyze the textual data mining. So there also this is very much useful.
Raju sir, where we condition probability, what is the definition and how we can use, and that introduction, and what is the theoretical part, and where you can these one the P of A and P of B, how we can the use in the application part also. Please explain, sir, our students.
Thank you, Dr. Vijay. As sir is explained about most of the application part, so I will explain mathematical part, the definition and what is the conditions involved in conditional probability. Okay, so what is a conditional probability actually? So probability of an event occurring given that another event has already occurred is known as conditional probability. It is denoted by generally probability of A given B. It can read as probability of A given B is equal to probability of A intersection B divided by probability of B. If you can write another form also, that another form is probability of A intersection B is equal to probability of B into probability of A given B. So where certain conditions we are defined whenever we are discussing about probability, conditional probability. So probability of A given B is the probability of event occurring given that has already occurred. Probability of A intersection B is the probability of both events are occurring together. So only we have to consider probability of B. It means probability of B is the probability of B occurring assuming that probability of B is greater than 0. So some few more examples I will discuss in terms of mathematical, in terms of notation basis. Already sir said a few examples and most of the real time examples. Okay, now we are going to discuss few examples along with notations. For example, if I take the first application part is student performance. If a student studies regularly, their chance of passing an exam is increased. They may get the good results. In terms of probability, let A be the event of passing the exam. Already happening event is what? Let another event we define, that is let B be the event of studying regularly. That means what? B event is already occurred. Then if B, that is we can represent in terms of probability of A given B. Which event is already occurred? B is already occurred. So probability of A given B is represents the probability of passing given that the student has studied. This is one example. So few more examples I will consider here. I will explain. So weather predictions, already sir said weather predictions. So how this is linked with our probability definition. If it is cloudy, the probability that it will rain is different than overall probability of rain. Here I can write in terms of mathematically, and we can two events are occurred. One is cloudy, another one is rainy. So let A be the event of rain, let B be the event of cloudy weather. Already known event is what? Cloudy event. That is a condition. So the probability of A given B is the chance of raining given that it is already cloudy. So traffic congestion. If there is an accident on a highway, probability of a traffic jam is increases. This is a general statement. Okay, so using this statement I would like to convert into as per our definition. Here two events are occurred. One event is A and another event is we can assume to be B. Let A be the event of a traffic jam. Another event is let B be the event of an accident. Then which event is already occurred? Accident is already occurred event. That is a condition. So let us find out what is the traffic jam condition. Okay, in that case we can represent like this. Probability of A given B is the probability of jam given that an accident has occurred. In terms of medical field, sir already said this. These are the few examples where we apply this conditional probability. So foremost important application is medical diagnosis. Here also we can apply conditional probability concept. For that, if I given one statement here, our statement is if a patient tests positive for a disease, the probability that they actually have the disease depends on how accurate the test is. Here how many events are occurred? Two events. First one is let A be the event that person has the disease. Let B be the event that the test result is positive. That means test result already knows. How we can represent it according to conditional probability the above statement? If the test has known sensitivity and specificity, the probability of A given B tells us how likely it is that the person has the disease given that they tested positive. So, these are the few examples that is converted into in terms of mathematical conditions.
Raju, this is all our applications?
These are applications. That application part I converted in terms of equation. So, theoretically we know the definition, but how our real data is converted into in terms of calculation part, that is why I can use this conditional probability definition in terms of notation.
So, the students will use this is the application part where they will use the medical diagnosis, and earlier you told they can use in the application part.
Yes, Vijay.
Good, sir.
So, for example, so how I can apply? I can explain few example problems which how conditional probabilities we can calculate making use of these examples. They may be clearly understand. A student may be understand so how to solve this type of problems. In a group of 200 computer buyers, 80 bought CPUs, 60 purchased monitors and 40 purchased CPU and monitors. If a computer buyer choose at random and bought a CPU, what is the probability that they also bought a monitor?
Yeah, this comes under marketing management.
Yes. The one of the example for the marketing, sir. So, this is a marketing example. So, few examples we are consider.
Yes.
So, how to solve this type of problem? If you carefully read this problem here, what in a group of 200 computer buyers, 80 bar. So, I clearly explain this. Let us denote two events here. So, according to earlier definitions, already given the 4 examples, how to convert it into terminology in terms of probability. So, let A be the CPU, let us denote A is treated as a CPU and let B is considered as a monitor.
So, this is the most important aspect in conditional probability, identifying the events A and B.
Yes, sir. Yes, sir.
So whether they are independent or they are dependent, or this has to be first known, then you can as well compute the conditional probability. That's what actually Dr. Raju is being explaining the solution of this particular problem.
Yes, sir. What Sari said exactly right. So, in that case, first we should identify how many events are involved in this problem. So, let us identify, after identify the events, then we can go for according to what are the conditions is mentioned in our problem. According to our problem, the first event is what? The first event 80 out of 200 bought CPU. That is, so what is the chance of probability A? The probability of A is equal to 80 by total outcome is 200. So, 80 by 200 is equal to, it is almost 0.4.
So, it is favorable by exhaustive.
Exhaust number.
Exactly.
So, favorable number of cases by exhaustive number of cases. So, our exhaustive number of cases are 200. Favorable number of cases are 80. So, that is, so
Raju, you are taking P of A is equal to 80 by 200.
80
so,
by
that
200.
output will be came.
So, that output is 0.4. Now, similarly, you can go for other item. Now, 40 buyers purchased both CPU and monitors. So, this is the intersection of the happening of two events.
Raju sir, you are taking in the second column independent and dependent, you are both are taking.
Yes, yes. But what the condition is already mentioned in your problem.
Exactly.
So, what the condition is mentioned here, hence that is according to that statement I can consider probability of A intersection B values. That means both, what is that? Both CPU and monitors already clearly mentioned. How many items here? 40. Exhaustive favorable number of cases are 40 and exhaustive number of cases are 200. So, therefore, probability of A intersection B is equal to what? 40 by 200. It is equal to 0.2. By conditional probability, already we given the definition. What is the conditional probability statement here? Probability of B given A is equal to probability of A intersection divided by probability of A. So,
Raju, what is the probability of A and the probability of B? Again, tell to the students, please.
So, probability of A is, so now go back to this. Probability of A is what here? CPU. Probability of B is indicate that what? Monitor. Okay. So, these are the monitors. So, now let us go for the what is the probability that a buyer bought a monitor. given that they purchased CPU. It's here condition. Condition is what here? A is already happened. B need to find out. So what is the condition here? Probability of B given A. What is the chance? Already we know that probability of 0.2 divided by 0.4. That already we calculated, that is. So
Exactly.
that simplified value is 0.1 by 2 means it is a 0.5.
So we are calculating the probability of B in the presence of probability of A.
A. Yes,
so
sir.
that is what actually. So whenever A and B events are there, the chance of occurrence of one event over the other
event.
is given by the probability of B given A.
Yes sir, yes sir, exactly. What sir said is exact. So finally, what is the percentage? 0.5 means there is a 50% of
Chances.
So that means the probability that a buyer bought a monitor given that they purchased a CPU is 50%. So this is one example. So another example, if you go for one more example for more clarification of the students. So I can consider one more example here, little bit of changing here terminology. So consider a family with 2 children. Some logical question here. Assume that each child is likely to be a boy as it is to be a girl. What is the conditional probability that both children are boys? Given that they are asking the 2. One is the older child is a boy. At least one of the child is a boy.
So these are conditions.
Conditions.
2 conditions they are clearly mentioned here. So based on this condition, we should define the which type of events are occurring here. Okay. So now based on this, we have to take sample space first. According to you have to define the sample space. So what are the chance here? Sample space. So S is equal sample space is represented by S. S is equal to boy is a one combination.
All exhaustive combinations are being, you have to consider under the sample space.
Those sample space values are boys comma boy. BB means boy comma boy.
First is boy, second is also boy.
Also boy. First is boy and second is girl.
Girl.
Then girl and second is also girl. Chance. Girl again boy. These are the how many sample space we have here? Total outcomes are 4. So now we can define the events. So let us consider A is what? Again 2 conditions are mentioned here. A is older child is a boy. Then B is represented as a younger child is a boy. So therefore, what is the A events here? A is equal to what is the possibility of A events here? B comma B, B comma G. At least, okay, B is equal to what? B comma B and G comma G. So therefore, what is the intersection of probability of A intersection B? Means common values. So both are, so it's only 2 combinations. What are those here? Boy and girl combination. So exhaustive number of cases are what here? So therefore, probability of A intersection B and number of outcomes, number of sample space. The total value probability of A intersection B is equal to 1 by 4. Then probability of A intersection means what? Both are boys. And A intersection B is equal to only B comma B. Then A union B means what? At least one is a boy. And therefore, probability of A union B is equal to, we need to find probability of A union B formula. So here conditions, probability of A union B formula already you know. Probability of A plus probability of B minus probability of A intersection B. So all probability A value we got, probability of B value we got, probability of A intersection B. All the values you can substitute here. We got one output, that is 3 by 4.
Raju sir, A union B you told that at least 1 by. It's mandatory here?
Here condition, first condition is given now.
Exactly.
First condition is given here. Now clearly mentioned here. The older child is a boy. The older child is a boy. Probability of A intersection B given A. That means what? Probability of A intersection B divided by probability of A is equal to what? Already we know what is your condition is what here? A intersection B. What I said A intersection B earlier?
So that is the A intersection B.
Already we know what is the probability of A intersection B. Already we know.
Yes, we know the value of that 1 by 4. So we are substituting here.
Here I can substitute here probability of A intersection B given that A is equal to 1 by 2. After simplifying this.
So 1 by 4 and 1 by 2 we are simplifying. By 4 and 2 it should be cancelled is equal to 1 by 2.
1 by 2. at least one of the child is a boy. That means probability of A intersection B given that A. That is why I ask, why we need to calculate this A union B? That is at least one, common set.
Exactly.
So that is why I can use this. So therefore, probability of A intersection B given that A union B is equal to, what is the formula here? Probability according to conditional probability definition. Probability of A intersection B, probability of A intersection B, intersection of A union B, divided by probability of A union B. Just like here the two events are occurred. Previously we have to write the only one. So but here in that case we have to simplify this. That is also we can write probability of A intersection B value, already we know that. So after simplifying this we got 1/3. So at least one child is a boy, is chance is what? 1/3. The older child is a boy, is chance is 1/2.
1/2.
So the older child is a boy, probability is 1/2. At least one of the child is a boy is 1/3.
So actually, I mean, Dr. Raju has already given the, everyday life examples like weather forecasting. So where the conditional probability is used to calculate the probability of rain given the presence of certain weather conditions. So where an unknown event and as well as a known event given that. So how do you calculate the conditional probability? So that's actually a real life situation. And also he has quoted the traffic conditions aspects, so accident and as well as these aspects which he has considered. And then so with this we can understand, all the students can understand that here whatever we study in statistical probability aspects, so definitely they are definitely it will be a application orientation. Only thing is you should identify in a correct aspects what events are you are dealing with, and then how you can as well calculate the conditional probability.
Now, sir, next to independent events, what is the independent events and how we can apply the conditional probability, independent events and conditional probability? When the random experiment and occurrence of E, any condition we are taking, we can call the events are independent. In case E is taking the may affect F, we call E F for dependent. What is the independent? What is the independent and what is the dependent? Sir, Gopal sir, please explain these independent events, for what purpose they will use in the application part, sir.
Yeah, so see, as we have seen it with regard to the conditional probability, so these independent events, say a happening of A is independent of happening of B. So these two are non-overlapping aspects. So if you want to calculate exclusively A and B independently, so then you have to consider what is known as the independent events aspects here, right? So this he will explain with all. This can be very much useful, and as I told you that here in most of the real life aspects. So here suppose if you want to know about the accidents aspect, what sort of independent accidents are being taken place in a day or in a month, etc. So and similarly here, how many days it is raining, and then is it a rainy day or it is a non-rainy day. So these are called as, actually they are the happening overlap won't be there in both the events, then that type of a situation is called as independent events.
Dr. Raju sir, you have to define what is independent events. P of A by B, what is P of A by B is equal to P of A. P of B by A is equal to what is P by B. Should explain to our students how it should be resolved, definition and their problem sum to give to our students.
Sure, Dr. Vijay. So as I said, according to independent events, so in addition to that we have to add few more things. So if you define this statistically or probability definition, what is independent event? So two events A and B, if I say definition, independent events definition, two events A and B are said to be independent if happening or non-happening of A is not affected by the happening or non-happening of event B. That means one is happening or non-happening, either other event is happening or non-happening. Okay. So, thus A and B are said to be independent if and only if the conditional probability of the event A is given that B has happened is equal to the probability of A. Earlier the definition is not like that. That is, now we can write here probability of A given B is equal to what earlier? Probability of A intersection B divided by probability of B. Now, in that case, probability of A given B is equal to probability of A when this condition is exist if probability of B is greater than 0. Similarly, we can define probability of B given A is equal to probability of B if when this condition is exist probability of A is greater than 0.
Raju sir,
Why?
P of A by B is, you told P of A, P of B greater than 0. Similarly, so we are taking P of A by B, that's why P of B greater than 0. P of B by A we can take a P of A greater than 0.
Yes, yes.
So P of, in the similar part, I am asking the question, P of A by B, we can take that P of A less than 0? It is possible?
No, because
Exactly.
denominator term is what here? So, probability means something will happen. Probability is always what? Lies between 0 and 1 only.
Exactly.
And division by 0 it will happen.
Division by 0 means it's null defined.
Yeah,
Exactly.
So, I mean, what Dr. Raju is explaining is here. See, we actually the Bayes theorem our main topic today. So this particular Bayes theorem uses these probabilities, that is called as a priori, posterior, and as well as the marginal aspects and the likelihood aspects. So actually we want to know that here, if you want to see all possible combination of the events, suppose if you consider only 2 events, and then what actually A given B, what actually A intersection B. So those things is being explained under this particular class of the independent events. To know more about the Bayes theorem, right? Over to Raju.
So, thank you sir. Then I will explain one example problem in that case, how independent events are occurred. So, shall I go for one example? Shall I discuss one example right now?
Yes.
So, in that example problem, Maha and Pranati took their driving test today. These two are in the events. One is event is what? Both Maha and Pranati took their driving test today. The probability that Maha passes the test is 7 by 10 and the probability that Pranati passes the test is 6 by 10. What is the probability that both pass their driving test?
So see, look here, Maha has scored favorably
7 by 10.
and then the exhaustive marks is 10, but her probability is 0.7, and then the same Pranati's probability is 0.6. So given these two conditions, so Mahati and Pranati are independent of each other and their test is common here. But thing is, the marks scored by Maha and as well as Pranati is 7 by 10 and 6 by 10. So given this situation, so how these two have, whether these two have really passed the test or what actually is the condition on this. So for that we just go for what is known as the independent events.
Sir, you told that both are same test has been passed, but they get different marks.
Different marks.
Independent.
Exactly.
They are independent to each other.
Yes, sir.
So then I will explain in detail. So let us denote. Okay, let A denote the event in which Maha passes the driving test, and B denote the event in which Pranati passes the driving test. Okay, how many events are defined here? 2 events. Okay, 2 persons are involved. Here A and B are independent events. Pranati is different, Maha is different. Okay, both are different events. So while you consider the test, Maha got how many? What is the probability of getting? We already, according to our given statement, probability of A is equal to 7 by 10. Probability of B is equal to 6 by 10. Probability that both pass the driving test. Both probability means there is a common. That means probability of A intersection B. That means here both events are independent here. That is why that intersection becomes what? Probability of A into probability of B we can write here. So, then already we know that what is the value of probability of A? 7 by 10 into 6 by 10. So, that what is the chance of probability that both passing the driving test is 21 by 50. So, this is one example for the independent, both are. So, what is the chance if they were considered both cases?
Raju sir, we are taking P intersection B here. So, both the tests are same, that's why we are taking intersection here?
Yes, yes, that is why. So, according to that, both are common, but persons are different, individual performance. Okay.
The independency among their performance, and there is a, we want to evaluate the commonality. Commonality between these two, because they both attempted the same test, but persons are independent.
Here persons are independent. What sir is said exactly. Persons are different, but
their
test
scores
is
also,
common.
their scores
test
also
is
different.
common. Test is common.
Test is common.
Test is common. Persons efficiency level is different. Now, one more events here, conditional event and independent events and multiplication theorem for two events. This is if I go for the Bayes theorem.
Raju sir, before multiplication theorem, how we can use, where we can use this multiplication, Gopal sir, where we can use multiplication theorem?
Yeah, that's what actually, see, just now Dr. Raju has given the example where the performance of Pranati and Maha, so they are independent. Their performance levels are independent as compared to the commonality among them. So, multiplication theorem is, see, it is actually the Bayes theorem is a combination of these independent events and as well as other aspects, and then you are also calculating the addition theorem of probability.
Yes,
and then you are collating all these aspects. If you have multiple event aspects has to be evaluated, so then you should also know that here what is the multiplication theorem of these two events which he has considered in the problem. So that he will explain in this particular case.
Sir, you told addition and addition theorem for two events. What is the difference, sir? Multiplication theorem and addition theorem.
So here you just talk about the independency there. In multiplication theorem, and there it is actually some sort of a dependency in the addition theorem.
Exactly.
Yes. There is a dependence in addition theorem. There is a independence in multiplication theorem. That is a difference.
Exactly.
Okay, that difference. Now, just I give the statement of the what is the multiplication theorem for two events. Let A and B are any two events. Then, so probability of A intersection B. So based on the conditions here, probability of A intersection B. Probability of A into probability of B given A, if probability of A is greater than 0, this is one condition. Probability of B into probability of A given B, if probability of B is greater than 0. Another condition is probability of A into B. When we consider this probability of into B, if A and B are independent.
So here Maha is independent of Pranati.
That is the example for the performance of the previous driving test.
Yes.
Now, coming to Bayes theorem. So, Bayes theorem and its application.
Before Bayes theorem, you can explain about additional theorem of multiplication. Additional theorem, you told now before the slide multiplication theorem. Addition theorem, you can.
Addition theorem is so total probability, that is nothing but the total
A
probability.
Union B.
A union B. So, A union B already you know.
You can do the sum
of the total
probability of A plus probability of B minus probability of A intersection B.
This is the
addition
theorem. Addition theorem. Okay.
Now we can discuss about the Bayes theorem. So, in the Bayes theorem, we can understand the Bayes theorem. The principle was given by Thomas Bayer in 1763. Sir, in Bayes theorem, what is the part used to our students, and this Bayes theorem, which applications should be used, and how can their process and they develop this Bayes theorem in their semester 1 or also in the future? Please explain to our students, sir.
Yeah, see, actually, I mean, as you advance your probability theory, you should first understand Bayes theorem is a combination of three probabilities we calculate or we consider rather. So that is a priori probability, then prior probability, and the other one is the posterior probability. or and as well as the likelihood. Right. So you are calculating the what do you call it, we are calculating the posterior probability, and then in the presence of the likelihood and as well as prior and marginal. So this is little complicated. So I want to first say that here, what is this a priori probability? So where is this can be, how do you calculate that, and as well as where what is the example of a priori probability? See here, a priori refers to a probability which is derived from experience, intuition or reasoning rather than empirical evidence of the data. See, like, so it is, the definition is so complicated. So we can understand, the students can understand better if you know the following examples. Like for example, suppose you want to estimate the probability of a new restaurant succeeding in a particular location based on our experience and as well as knowledge of the local market. We might assign an a priori probability of 0.7. So that is 70% to the restaurant succeeding. So you already have a restaurant in a particular location, and then suppose if I say that here, if I launch a restaurant or already it is there, what is the performance of that? So that is called as the a priori performance. So that is what actually is called as a priori probability. Bayes' theorem takes that particular a priori probability. Next is the prior probability, right? So prior probability is the probability of an event or hypothesis before new data or evidence is taken into account. See, that's what actually prior probability. So we just take an admission that with a thumping statement stating that here you will pass in distinction. So that is the prior probability without happening that particular this thing. You do that here. Example is that here, suppose we want to predict the probability of a person having a disease, right? So based on the prevalence of the disease in the population, we might assign a prior probability of 0.01, so 1% to the person having the disease. So this is called as actually the prior probability. So similarly, Bayes' theorem is having a prior probability, a priori probability, and as well as the marginal probability. So marginal probability is the probability of an event occurring without considering any other events. So like if you just take it, the example of Dr. Raju just now said, so passing the test by Maha and as well as Pranati is independent of each other. So their probability is occurrence in that particular example is probability of test passing is 0.6 and the other event that is 0.7. So that is what actually is called as the marginal probabilities. So therefore the theorem, so what is the likelihood of happening of a particular event given the event's probability is being a combination of all three put together forms into a Bayes' theorem. So that Dr. Raju will explain now.
Yes sir, that is the application part sir is explained in detail. So now I will go for a small definition and some mathematical terminology. So one of the important application of the conditional probability is the computation of unknown probabilities on the basis of the information supplied by the experiment or past record. For example, suppose an event has occurred though one of the various mutually exclusive events or reasons, then the conditional probability that it has occurred due to a particular event or reason is called a inverse or posterior probability. Sorry, said already this terminology, but what is the actual definition of inverse or posterior probability? So these probabilities are computed by Bayes' theorem named so after British mathematician Thomas Bayes, who pronounced it in the year already mentioned. The old revision of the old given properties in this list of the additional information supplied by the experiment or past records of the experiment help in arriving at valid decision in the face of uncertainty. So, what is the definition of the Bayes theorem actually? The Bayes theorem is, another word is rule for the inverse probability. We can use another terminology also, that is rule for the inverse probability. If I define the statement, so the statement of the Bayes theorem is, let E1, E2, E3 and so on En be n mutually exclusive events in the sample space S with compulsory probability of EI is not equal to 0.
Raju sir, what you told PI not equal to 0. If equal to 0, what is the problem?
That means if any equal to 0, that is we have can't identify the what is the estimated value. So we can't find that value become 0 means the total value goes to 0. In that case, we
so
cannot.
They did not finding the value.
We did not
here.
find the value, any value of the given statement.
Our ultimate goal is that here to estimate the posterior probability.
Exactly.
So when if any one of these events becomes 0, then definitely posterior probability becomes 0. So hence it is not possible. That's the condition under the Bayes theorem.
Bayes theorem. So that is why we are taking probability of EI not equal to 0 for all the values. Then let us consider how many number of variables in how many events are considered. All the events must be happening. Okay. So
occurrence is assured. Then only you can go
Then
for a Bayes theorem.
Bayes theorem. Sir. So let A be any arbitrary event. If I choose one event, I want to identify this event. Okay. Let A be the any arbitrary event which is the subset of union of all the events. That means union of I is equal to 1 to n E high terminology such that probability of A is greater than 0, then probability of EI given A is equal to probability of EI into probability of A given EI divided by last one is what is the summing over I is equal to 1 to n probability of EI into probability of A given EI. That is nothing but total probability.
Raju sir, you told that union of I is equal to 1 to 1 EI, PI greater than 0. If less than 0, it should be what is that value?
So less than 0 is not happening means something will have.
Exactly.
Something will happen means it is event is occurred. Otherwise we can't define that statement. Okay. So this is for all I takes a values 1 to how many variables. If the 2 variables, formula is applied 2, 3, 4, 5, whatever the number is given, you can substitute here, we can get what is the value is required to calculate. This is the general formula for Bayes theorem. That is probability of EI given A is equal to probability of EI into probability of A given divided by EI.
So what Dr. Raju meant is that here general formula for Bayes theorem is this. So that indicates that here you can take any number of events and calculate the Bayes theorem.
Yes sir. What sir?
So, suppose if it is only 2 events, it will be only you are doing it for only A and B.
Yeah.
So then Bayes theorem can also be the minimum is that here you should have at least 2
and above
events, 2 and above, any number. That's the reason this particular generalized formula is being shown in the screen.
So E1, E2, E3, these are exclusively events.
So here I mentioned here that probabilities what? Probability of E1, E2 and so on, En are known as the a priori probabilities. These are. But sir is already explained about what is the a priori probabilities, what is the likelihoods. Okay. So known as a priori probabilities because they exist before we gain any information from the experiment itself. Already these events are already happened. So the probability of A given EI, I takes a values 1 to n is called likelihoods because they indicate how likely the event A under consideration is to occur given each and every a priori probability. That means one is priori probabilities and another one is likelihoods. So The probabilities
Raju
of
sir, you have written P E by A is equal to 1 to n, and earlier slide you have to P A by A. What is the difference?
that is I already said likelihoods and a priori probabilities
Yeah.
and likelihoods.
Exactly.
Okay, then the probabilities of EI given A is equal to I takes a balance is called what? Posterior probabilities. These are. So what are these first priority probabilities? What? First one is a priori probabilities. Second one is likelihoods. Third one is posterior probabilities, because they are determined after the results of the experiments are known. That is why that is known as a what? Probability of A is equal to summing over I is equal to 1 to n probability of A into probability of A given EI is known as total probability.
So the posterior we are going to estimate
after
given these likelihoods and marginals and as well as the prior
probabilities. So most extensively already sir discussed the examples. Now in generally once again I give the few statements here. Bayes theorem is extensively used in business, management and engineering executes in arriving at valid decision in the face of uncertainty. If any uncertainty is there, then we can apply this. Not only this one, we can use so nowadays we are getting the many swap mails. How to filter this swap mails in terms of in our Gmail or another accounts.
Not only that, see nowadays it is all actually data analytics and as well as the deep learning aspects and robo technology. So in most of the robotics, Bayes theorem is very much used. So this can calculate the probability of different robo states given the sensor data. So this most of the mechanical engineers and etc. So they use in this Bayes theorem. So how the robo given a particular probability, how does the sensor works? So if the sensor works very less, then definitely the robo is not performing well. So that is one aspect. The other aspect is that here in most of the AI, artificial engineering aspects, artificial intelligence aspects and as well as the machine learning aspects. So this Bayes theorem works very much useful. Suppose if the events are many, occurrences are many, so then you have another technique called as hidden Markov models. So that also is being used using this sort of a probability aspects and then calculate these aspects.
Sir,
yeah.
Sir, Raju sir told that business and management and engineering. So it's a majorly we can using the valid decision. It should be 100% or any less than percent.
100% exactly. So now it's moreover in deep learning also sir said in deep learning. So this is the most of the important things are discussed in deep learning also.
And so also this is also is used in most of the reliability engineering.
Exactly.
So reliability engineering also, so like manufacturing, in most of the manufacturing units, if a manufacturer manufactures a particular unit, and then what is the reliability of that particular this, how long it will be using it, and how long it will be having its lifetime.
Lifetime of the any particular event.
Yeah.
Particular event.
So these are the various applications of Bayes theorem.
Yes. Please continue, Raju.
So now I'll explain one example problem how Bayes theorem is applied for this data. So for example, in a factory manufactures bolts, machine A, B and C. I can apply for this Bayes theorem for 3 events. What I earlier said, at least 2 events are required. Now I am going applied here 3 events here. Those events are A, B and C. Manufacture respectively 25%, 35% and 40% of the total of the bolts. Of their outputs, 5, 4 and 2% are known to be defective bolts. So means in any manufacturing unit, some default in default have some defective items. Okay, of their outputs are what here 4 and 5 and 2% are known to be defective bolts. A bolt is drawn at random from the production and is found to be defective. What are the probabilities that it was manufactured by machine A, machine B, machine C? Okay, so now I would like to find out this. Let us assume 3 events E1, E2, E3B denote that event that bolt selected at random is manufactured by machine A, B and C respectively. Let E denote the event that it is defective. I would like to find which value? Defective item. Then we have already given probability of E is what is the percentage? 25%, that means 0.25. Probability of E2 is 35%. Probability of E3 is equal to 40%. So, given that probability of E given E1, that means probability that bolt run is defective given that condition is that is manufactured by machine A. Already clearly mentioned. Defective item percentage is also given in our question. Okay, that is 5%. That is 5% means 0.0. Similarly, already given the two more events, that is probability of E given 1 and E given 2. That values, remaining values are 0.04, 0. So therefore, the total probability we need to find. What is that? Summing over. So total probability is what? What is the definition? Summing over probability of EI into probability of E given EI. That means if I take I is equal to 1, first event, that is 0.25 and this. If I consider I is equal to, I got this one 0.35 into 0.04. If I consider the third event 0.4 into 0, the total if I multiply and adding and total output is 0.0345. This is what total probability. After getting this total probability, I would like to find out what are the questions they are asking here. Hence the probability that a defective bolt chosen at random manufactured by factor A is given by Bayes rule. So what Bayes rule? Already we know that probability of E1 given E. That means, so the event is what is the probability of E1 given that probability of E given E1. So already you know this value. Probability of E1 value is 25%. That is probability of defective item chance is 0.05. Then what is the total output here? 0.035. If I simplify means what? 0. How much chance here? 36% is bolt from the manufacturer A. Similarly, we can calculate the manufacturer B and manufacturer C, that is 0.41 is the default item, that means 41% here. If I take the third event, that third event is C, that is 23%.
రాజు సార్ మనకి ఇచ్చిన మూడు విలువలు ఏవైతే ఉన్నాయో E1, E2, E3 మూడు అయితే ఉందో అవి తీసుకున్నాము. అవి తీసుకొని అంటే ఫస్ట్ P E1 by E ఉంటే ఫస్ట్ దాంట్లో E1, సెకండ్ దాంట్లో E2, సెకండ్ దాంట్లో E3 అంటే ఆ విలువల్ని మనం అక్కడ సబ్స్టిట్యూట్ చేసి మనకు కావాల్సిన వాల్యూస్ ఫైండ్ అవుట్ చేయడం జరుగుతుంది.
సో moreover we need to check total output becomes what? 100%.
Exactly.
We can adding these all the three 0.36 plus 0.41 plus 0.23. How much? That is 100%.
Exactly.
So that is also we can easily, that is one of the important properties. So that means we need to find. Then similarly we can go for second example is also we can explain like this only.
So actually Dr. Raju, this example is actually a direct aspect where I mean you have the data and then done it here.
Yes.
So I suggest the students that here this is actually a ready-made problem. So in reality, like for example, if you just take a robo, right? So in robo, so it should walk. What is the chance that here it will fall down? Right? And similarly limbs, how the hands are working, how the voice is working. So all these things, if you note down these probabilities, I mean if these events, and then you can as well say that here the robo is successfully performing the job.
Yes,
exactly.
So these are the aspects the students innovatively get the data. So ready-made examples are pretty easy to put it in the formula.
Yes.
But in reality, artificial intelligence aspects, then raining, so in meteorological aspects. So how you are doing it? So these are the ones which you as a student, you should develop this sort of a innovation and then get the real data and then I mean calculate the Bayes theorem aspects.
Yes, sir.
So that is how it should be. So a student should do these aspects and get the things done
in their real life, sir.
Yes,
in their real life.
Yes.
Sir. Definitely if you apply this terminology, get the information, apply, then they'll get real time environment things like they're going to do their projects and other things, then they can apply this type of theorems and other related informations.
If you do this sort of a thing, you are beyond the regular churn, and then you are really wanted. by the the job market.
So nowadays industry also wants this type of students only, innovated like this, thinking behind their curriculum.
Please, Raju.
So these are the one example. So the continuation of the Bayes theorem. One more example problem we selected here. Select E1, E2 here. 2 events I can choose here. Selected from the, so that before that just you check this. In a railways reservation office, 2 clerks are engaged in checking the reservation forms. On an average, the first clerk check 55% of the forms, while the second does the remaining. So the first clerk and error rate is 0.03 and second has error rate is 0.02. A reservation form is selected at random from the total forms checked during a day and is found to have error. Find the probability that it was checked by the first clerk by the second clerk. So here I can say how many events? Only 2 events. So already conditions, whatever the things already clearly mentioned. Here I can select the 2 events, E1 and E2. So E1 is represented, the selected form is checked by the clerk 1, E2 is represented by the selected form is checked by the clerk 2. E is the selected form as an error condition. So then we have given, already given in your question, probability of E1 is equal to 55%. Made clerk 1 made a mistake, chance is only 55%. Then probability of E2 is equal to 45%, that is 0.45. Probability of E given E1 is equal to, already this is condition is already given, 0.03 and 0.02. Now we can apply the Bayes theorem statement. We have how many events we need to find here? Probability of E1 given E and probability of E2 given E. By Bayes theorem, probability that the form containing the error checked by the clerk 1 is 0.647, clerk 2 is 0.352. Or else we can know the first one, then we can easily find the second one, because total probability is always 1. This is the example for the Bayes theorem.
Sir, this is the Bayes theorem we are using in the application part also. Raju sir told and Gopal sir told. Sir, where some more applications is there for using this Bayes theorem, sir?
Yeah, this can be used in image and speech recognition problems. So where you want to calculate the probability of different images of our speech patterns given the input data. So Bayes theorem can be applied. Then in as I told you that here NLP, so natural language processing.
Yes.
So Bayes theorem can be used to calculate the probability of different words or phrases given the context. So then robotics, as I told you that here. So this can be used to calculate the probability of different robo states given the sensor data. So in these particular aspects, so Bayes theorem is very much useful. So that means, so in olden days, people used to calculate the Bayes theorem, use the Bayes theorem in most of the marketing and aspects. But in reality, nowadays, with the increase in computational problems, so this can be used in most of the natural language processing aspects, pattern recognition aspects, and in most of the image analytics, etc.
Yes. Sir, thank you very much, sir. You given the BSc semester, first semester students conditional probability and independent events and Bayes theorem. What applications ఎలా వాడతాము, రియల్ లైఫ్లో ఎలా వాడాలి, మనకి ఇచ్చిన జనరల్ ప్రాబ్లమ్స్ కాకుండా వాళ్ళని ఏ విధంగానైతే మనము వాళ్ళ రియల్ లైఫ్లో వాడడానికి ఉపయోగపడే విధంగా మీరు చెప్పారు. వాళ్ళు ఇవన్నీ నేర్చుకొని వాళ్ళు ఉపయోగపడతారని ఆశిస్తున్నాను. ఇవన్నీ నేర్చుకొని ఉంటే రియల్ లైఫ్లో బాగా ఉపయోగపడతాయి. మా విద్యార్థులకు ఇంత మంచి సమాచారం ఇచ్చినటువంటి ఆచార్య హరగోపాల్ గారికి మరియు డాక్టర్ ఎన్ రాజు గారికి మరియు మా మిగతా సిబ్బందికి కూడా నేను ధన్యవాదాలు తెలియజేసుకుంటూ ముగిస్తున్నాను.